Good morning, students. How are you? Hope you are all in the pink of health. I am Atun Roy, and you are watching Bond Making and Bond Breaking channel. From today, I am going to start freshly from class 11. Okay, so the first chapter from class 11 is some basic concept. So I will start some basic concept with depthly and line by line from NCRT. Okay, so firstly I'm going to talk about atoms. Okay, firstly I am going to talk about atoms. So atom means this is nucleus. Nucleus contain neutron and proton, and electron is revolving around the nucleus, and electron contain minus charge, where proton positive charge and neutron is neutral. Okay, those factor is very familiar to us. Okay, so electrons are revolving around the proton and neutron, and togetherly proton and neutron is called nucleus. Nucleus and electron contain negative charge and proton contain positive charge, and it is observed that by it is proved by Rutherford that proton take the small amount or small portion of the atom. Okay, nucleus occupy the small portion of the atom. Okay, and atom and together, atom plus atom and so on, it's form molecule. It's form molecule. Okay, it's form molecule. So this is the spinal cord, this is the backbone of chemistry. Okay, this is the backbone of chemistry. So what's the important of chemistry? So first point is important of chemistry. What are the importance of chemistry? The first important is for medicines. Huh? Just like analgesic. First point is analgesic. Analgesic means to it help to remove the pain. Okay, analgesic means it help to remove the pain. So we have great role on medicines, just like analgesic, pyretic, just like antipyretic, just like paracetamol, right? So we have a great role on medicines. So and we can also use in as a antiseptic, just like Dettol has composition of chemistries component. Okay, so as analgesic or maybe antipyretic or maybe antiseptic, what are the part of the medicines, there are various and vital role of chemistry. So this is one of the best important part of chemistry. It helps on the medical department, or helps the medicine to form the medicine. So we call it chemist. Okay, and the second one is tranquilizer, maybe it's tranquilizer, analgesic, antipyretic. Okay, so these are the vital role. And secondly, to preserve the food. If we want to preserve the food, we have to use chemistry. We can't avoid chemistry to preserve the food. Preserving food is very essential. It is very important for business purpose also, and to preserve the food at home also. So important of second part of important of chemistry is preserving food. So first one is on medicine. First one is medicine, and the second one is preserving food. And third one is hydrogenation of oils. Hydrogenation of oils. Through hydrogenation of oils, we can prepare oils or oils like product just like ghee. Okay, just like ghee. So those are the important factors of chemistry. Okay, and the second point next is nature of matter. Nature of matter. So we can classify the matter. We can classify the matter into three categories. We can classify the matter into three categories. As we know all that one is solid, another is liquid, another is gas. What are solids? Solid means the atoms or molecules or ions are closely packed. Right? Atoms or molecules are closely packed. As it is, the atoms behind it are closely packed. Therefore, the force of attraction between the atoms are very high. So, the force of attraction between the atoms or ions or molecules are very high. Therefore, it forms or it shows us rigidity. It's a very high rigid power. So the force or the attraction between the molecules or the attraction between the ions or the attraction between the atoms are very high. So this is solid. And the melting point and boiling point, the melting point as well as the boiling point is very high compared than the liquid and gas. Okay, and the liquid, as you all know that the force of attraction between two atoms in liquid is not more compared than solid. Okay, because there is gap between two atoms or ions or molecules. So the force of attraction between two atoms is not higher compared than solid. So the melting point and boiling point also. So the melting point and boiling point as well as the rigidity are also not higher, not much higher, or not higher than the solid. And the gas. Here the distance between two atoms. Here the distance between two atoms are very higher compared to solid and liquid. So the force of attraction is very less or very less if we compare with liquid. Okay, so the atoms or ions or molecules in gaseous form, they can move randomly. So those are the gases. So the boiling point, and melting point is very low compared than solid and liquid. So solid, for the huge force of attraction, solid has fixed shape and size, shape and volume. Okay, shape and volume. But liquid has fixed volume, not shape, due to the gap. Okay, due to the smaller rigidity, and the gap between two atoms in gas is very high. So atoms can move randomly. So there is no fixed volume or fixed shape. Those are the basic things of matter. Okay. Um, if we compare the matter, we can also classify it into two categories. One is pure substance. And another is mixture. Okay, pure substance and mixture. Pure substance means all the microscopic or bulky level matter can be classified as mixture or substance. These are further subdivided Mixture may be two types: homogeneous mixture, right? Homogeneous mixture and heterogeneous mixture. Heterogeneous mixture and pure substance we can further classify it into two groups, pure substance, that is element, and compound. Element and compound, that's it. So we can classify matter according to the all the basis, the attraction between atoms, solid, liquid, and gas. So we can say the solid has fixed shapes, so volume, the fixed shapes and volume. Liquid has volume but not shape. Gas has no fixed volume, no fixed shape. Further, we can classify matter into two groups: pure substance and mixture. Pure substance can classify into two categories or two groups: elements and compounds. And mixture further can be classified into two types: homogeneous mixture and heterogeneous mixture. What are homogeneous mixtures? Okay, homogeneous. If suppose you take 1 glass of water, you add sugar. What will you see? What will you see? You cannot find the sugar. You cannot find the sugar in water. In your penis. Okay, so you can't find sugar in water with your open eyes, right? So this type of mixture, but the properties of sugar you can taste it. Okay, so this type of mixture is called the homogeneous mixture, where sugars are completely soluble in water. That type of mixture is called the homogeneous mixture. And on the other hand, what a heterogeneous mixture? Heterogeneous mixture, that means suppose you have taken a glass of water. You have taken a glass of water, one glass of water, and you add sand. You add sand. Is it possible for sand to mix with water? It's not. Therefore, this type of mixture is called the heterogeneous mixture. The common sense, okay? Okay. Now, what are the elements? Element means it may be hydrogen, oxygen, nitrogen, fluorine, neon. This type of compounds, this type of atoms, we can say it elements. And compound means when elements are joined together, mixed together, react together, then on that time they form molecules. Suppose you have oxygen and oxygen, two oxygen atoms, two oxygen elements. When it combine together, it forms O2. At that time, O2 is called compounds. At that time, O2 is called molecules. O2 is called molecules. Atom, 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 and O2 is molecules. Right? And O2 is molecules. And when hydrogen and oxygen mix together and form H2O at that time, that is compound, and CO2 at that time, it is compound, and also molecules. Okay. Properties of matter and their measurement. Properties of matter and their measurement. Properties of okay. Properties of matter and their measurement. So properties of matter, we can classify properties of matter. We can classify it into two groups: physical properties physical properties and chemical properties. Physical properties and chemical properties. What are physical properties? Physical properties means we can observe it with our open eyes, or just like you have cold water and hot water. Cold water and hot water. You, by just touching you can feel or you can say is it cold or is it hot. So if you can say through this type, so this type of properties are called the physical properties. Okay. If you say that A is react with acid and form B, the properties of B these, but you can't observe, you can't see the reaction. You can't see the reaction with your open eyes. Okay, you just think with logic and give your answer. This reacts with acid, so it, as the properties of A is this, so the product will be the properties of B this. So you just think with your logic. Yeah, acid reacts with, if it is metal, so metal reacts with acid, so this is the logically this will form. But the what the reaction in between them you can't say. So those are the chemical reaction and chemical reactions, and those properties are called chemical properties. And physical properties, we magnetic properties, and by touching, by seeing, by smelling, whatever we have done physically, that properties are called physical properties. Okay. Now the units are now the units are now the units are basic units, just like length. Okay, just like length means meter. Units can show through SI or CGS or FPS. Mainly we calculate through CGS or SI, that means meter or centimeter. We can convert meter to centimeter and centimeter to meter according to your question paper. Okay, those are the length. And mass also kilogram and gram, so you can convert kilogram to gram and gram to kilogram. Time, the standard unit of time is second. Okay. Then electric current, so electric current, the unit of electric current is ampere. So those are the basic units. Okay. And thermodynamic temperature thermodynamic temperature, that is Kelvin, right? Amount of substance, amount of substance, the amount of substance, that is mole. We came to know that 1 mole any substance, that means 6.022 into 10 to the power 23. 1 mole carbon dioxide, that means 6.022 into 10 to the power 23 number carbon dioxide. 1 mole ammonia, that means also 6.022 into 10 to the power 23 number ammonia. 1 mole C6H12O6, that is also 6.022 into 10 to the power 23 glucose, right? So amount of substance is measured by mole unit, okay? And luminous intensity, that is candela. Luminous intensity, that is candela. So those are the basic physical quantities and their units: length meter centimeter, mass kilogram, time second, electric current ampere, thermodynamic temperature, that is Kelvin. You can convert the temperature of degree centigrade T plus 273 and convert into Kelvin. So thermodynamic temperature Kelvin, amount of substance mole, as we know that, as we say that 1 mole contains atom number of that compound, amount of substance, and luminous, that is candela, okay, that is candela. Length is measured by scale, okay, and you have to remember also some few changes, just like um, 10 to the power 10 to the power 6, that means mega, okay, 10 to the power 6 means mega, and 10 to the power 9 means giga, 10 to the power 9 means giga, right? Then 10 to the power 12 is 10 to the power 12 is tera, 10 to the power 12 means tera, 10 to the power 15 means penta, 10 to the power 15 means, sorry, peta, and 10 to the power 18 means exa, 10 to the power 18 means exa, 10 to the power 21 10 to the power 21 means zeta, okay, and 10 to the power 24 means iota. So you have to remember that type of terms. Now I am talking about density. Density means mass by volume. The unit of mass may be kg or maybe gram, and the unit of volume may be meter cube, may be centimeter cube. So the final unit of density in SI kg per meter cube, or you can also write kg dot meter to the power minus 3, or gram per centimeter cube, or you can say gram dot centimeter to the power minus 3, okay. And the temperature, if you want to convert, those are the basic things, okay. If you have temperature on degree centigrade and you want to convert it degree Fahrenheit, so the formula is C by 5 is equal to F minus 32 by 9. Suppose the value of centigrade is, the value of temperature in centigrade scale is 30 degree centigrade. What will the value through in Fahrenheit scale, okay. Just put the value 30 by 5 is equal to F minus 32 by 9, 5 6 are 30, so 6 9s are 54. 5 minus 54, that is 54. 54 and Fahrenheit Fahrenheit is equal to the value of Fahrenheit is equal to 54 plus 32, that means 86 degree Fahrenheit. So 30 degree centigrade means 86 degree Fahrenheit. Okay, or we can easily say degree Fahrenheit is equal to 9 by 5 degree centigrade plus 32. Okay. Okay. So those are the normal concept. From the next class we will be continuing. So thank you. Keep studying, keep watching, and take care of your health. Goodbye.